So I got a really cool, awesome speaker with me on this one. I have Tyler Hawkins, and I'm going to bring him in here. Hey, Tyler, what's going on, man?
Hey, Mike, how you doing?
Where are you? Where are you located anyway? Where are you?
I am in Utah, good old
You're
US.
You're in Utah, dude. I love Zion National. Okay, for a minute, offline. I love Zion National Park. I love your parks. They are the most super amazing parks, aren't they? I love your state, by the way.
They've got some good hiking, good skiing out here too.
Oh man, I know. Okay, that was just a little advertising right there for Utah, right? Just kidding. Anyway, Tyler, what you got for us today? What are you going to talk about?
So we're going to talk about the Node.js event loop. It's all about the internals of how Node works.
Man, that sounds so super cool because I saw what you were presenting. I said, oh man, I am going to pay attention to this. So what I'm going to do here, I'm going to bring in your slides. I'm going to get off stage and you got it, bro. Have a real good.
Awesome. Thanks, Mike. All right. Well, thanks everyone for being here. I'm excited to talk to you guys today. So as we said, we're going to talk today about, the talk title is Understanding the Node.js Event Loop. We have a whole bunch of code examples to go through today. So if you want to follow along or just play around with this afterwards at some point, you can find the GitHub repo. It's at github.com/thawken3/Node.js event loop presentation. Just briefly a little about me. My name is Tyler. I'm a senior software engineer and tech lead at Adobe. I've been doing software engineering for about a decade now. If you want to connect with me, you can find me on LinkedIn or Twitter. I also love to write, so you can find me on Medium and several other tech blogs as well. So with that, let's dive in. So we're going to talk a little bit about, first off, the JavaScript event loop, as opposed to the Node.js event loop, which are in fact two separate things. And so if you were to Google the JavaScript event loop, what you'll find is about 50 results, all of the same variation of this image. Everyone loves to create this exact same little diagram. But this is a very simplified model of how the JavaScript event loop works. And with the JavaScript being single-threaded, the event loop is what helps JavaScript with concurrency and being able to do things asynchronously. So when we talk about code, we have synchronous code that basically reads top to bottom, and then we have asynchronous code, so things like callbacks and promises or timers, so things that can get kicked off, they wait for a little bit, and then eventually they run. And so the event loop's job here is really to coordinate the work between a couple of different things inside this model here. And so looking through the diagram, we have this heap, which is really just like this somewhat unstructured set of memory where you can, where all of your objects and functions and variables get stored. You have a call stack, and as your functions get executed, they are pushed onto the stack. And then as they finish executing, they get popped off of the stack. And so if you think about the stack, the data structure type, right, it's a first in, last out data structure, or last in, first out. You can think of it like a stack of dishes as it piles up, and then you take the top dish off the stack until you're left with nothing. And then we also have this callback queue, which a queue is a first in, first out. So you can think of a queue as a line at a checkout aisle. First thing into the queue is the next thing to go out. And so with JavaScript, as functions are being called, they go onto this call stack, and then they might make some external calls to these web APIs. So things like interacting with the DOM. So maybe this is again in the browser, and so the DOM, maybe a user clicks on something, and that would then trigger like an on-click callback. You might make an API request, so something with Ajax, you're going to go make a network request, grab some data, and then come back with the callback that executes after this request finishes. Or you might have some timers, so something like setTimeout or setInterval, where you make sure that there's a delay, and then as soon as that delay happens, the stuff goes onto the callback queue. And so the event loop's job here is really to monitor the stack and the callback queue, and to control the execution of the order, or the execution order of when these functions are called. And so as long as there are things on the call stack the event loop is going to just keep executing those functions. And then once the call stack is empty, the event loop will check if there's anything in the callback queue. And if there is, it'll take that next method, it'll pop it or push it onto the call stack, and then start executing that. And then once that call stack is empty again, it'll come back to the callback queue, grab the next thing. And it goes on in this loop pretty much as long as your program is running. And so if you wanted to look at, maybe an example of something filled out, maybe you have some example code where you have a method foo that gets called, and then foo calls bar, so that goes onto the stack. And maybe bar makes an API request, so it comes over here, so it kicks something off to this external web API, and then also calls a console log. And then these will finish executing, so the console log is gone, that gets popped off the stack. Then bar will finish executing, that gets popped off the stack. Foo finishes executing, that gets popped off the stack. And then eventually we're left with maybe this API request completes, which then pushes this callback method into the queue. Call stack is empty, so the event loop picks that up and then puts it onto the call stack. And so that's the simplified model of how the event loop works. If you're like me, I like working examples a lot more than just looking at diagrams. And so to help understand some of these concepts, we're going to run through several code examples. And so we'll get a good feel for how this JavaScript event loop works. And then from there, we'll start digging more into the Node.js event loop, which is a specific implementation of this event loop. So let's dive in. Let's do some code. So for all of these examples, they're going to be relatively straightforward, pretty short and simple. If you want to play along at home, you can guess the order in which things will run, throw it in the chat, or just think about it. And yeah, we'll run these and we'll talk about them. So let's start with the first one. So this is synchronous code, extremely straightforward. We've got 3 methods here, first, second, and third. That's simply console log. And then we call them first, second, and third. And so if we were to run this, we'll execute over here in the top right, exactly in the order you would expect, first, second, third, right? And so synchronous code, it's read pretty much top to bottom. They'll execute in the order that they're written. So no real surprises there. So now let's look at the second example. So synchronous code, we have things like loops, so like a for loop or a while loop or a do while loop. So what if we ran this in a loop? We still have our same first, second, and third methods. And so what we'll do is we'll call the first method. And then inside of a for loop, we'll call the second method 5 times. And then we'll call the third method. So what's going to run here? So we're going to run this. We'll go to our second demo. And you can see it executed in exactly the order you'd expect. We've got our first, then we're in this for loop. We're running our second method 5 times, and then third. So again, this is synchronous code, which is also known as blocking code, where the code isn't going to move on down the screen from top to bottom until the functions have finished executing. And so we're basically stuck in this for loop until it runs out, and then we can move on to third. So far, we've had functions that don't call each other. They just do their thing, and then they're gone. So looking at something more involved with the call stack is maybe you'll have a function that calls another function. And so in this case, we have our first function on line 1 that just does a console log. Our second function is going to do a console log, and then it will call the third function. And then the third function will just do logs, and same with the fourth. And so now as we run our code on lines 9, 10, and 11, let's see what happens. So let's run this demo. And again, it's going to run in pretty much the order you expect, hopefully. So we've got first, we've got second, and then second then calls third. So console logs that. So it's, again, kind of building up that call stack, and then the functions are being popped off as we go. And then we get to fourth. So again, we're still in synchronous land here, just running stuff top to bottom. If you want to look at a slightly different example with the call stack, rather than calling third directly, maybe we update the second function so that it accepts a callback and then executes that callback. So now with that exact same setup, we're going to call first, and then second, which will then call third, and then fourth. So if we were to run this again, you can see we're still in the same order that we expect, first, second, third, fourth. And so that's synchronous code. And so when we want to start thinking about asynchronous code, one of the first methods that we can think about is setTimeout. And so setTimeout is a method that will allow you to execute a function after a certain number of milliseconds have expired. And so let's run through this one. So we've got our first, second, and third. Again, they all just do console logs. We're going to call first. Then we're going to call setTimeout to execute our second function after 1,000 milliseconds or 1 second, and then third. And so if we run this example, you can see we've got first and third, and then second is run. And so now we're starting to get into this asynchronous nature of JavaScript. And so first ran, and then the call to setTimeout ran, but it doesn't execute this function immediately, right? We're going out to these external APIs where it works its magic, and then we'll eventually push it onto that callback queue. And so while that's happening, we're just going to continue down the screen. And so then it gets to third, and then after the 1 second has expired, it will run second. So then you might look at another example. Maybe we have a setTimeout, and this time we say 0 milliseconds. So what's going to happen here? We call first, then setTimeout with calling the second method with 0 millisecond delay, and then third. Just a second to take a guess. All right, we're going to run it. Okay, so we got first, third, second. Now this is where it might surprise some people that are maybe new to JavaScript. And you might think, why did second run last? If it's a 0 millisecond delay, why not just execute immediately? And the reason for that is if we think back to the event loop, is that it's going to execute first, then it's going to make the call to setTimeout. So it's going to go over to the web APIs, and then it will push that once the time has elapsed of 0 milliseconds. It'll push that onto that callback queue. But we're still working through our call stack right now of just this main module that we're executing. So we're still going to run third. That's going to execute first. And then now that the call stack is empty, the event loop will pick up the next thing off of the callback queue, and it will then put it onto the call stack. And so that's where we get this delay. And so this is a useful method if you want to delay the execution of something to the next tick of the event loop. So there we go. That's setTimeout. So let's look at one more with setTimeout. And with this one, we're going to try to block the event loop. So again, we still have our first, second, and third methods. They're just going to do some console logs. So we'll call our first method, and then we'll call setTimeout with second, again with a 0 millisecond delay. And then we're going to call third inside this while loop. And what this does here is basically just creates this while loop that's going to be blocking the main thread for 5 seconds. And so let's take a look at what happens here. Okay, you can see it's running third. It's going to keep on running that for 5 whole seconds. And then we finally get to second. And if we scrolled all the way up to the top, you'd see that first was the first thing to console log. So this demonstrates another interesting principle and a good point is that when you schedule something with a timer, so something like setTimeout, this number here that you've put for the delay is not a guarantee that it will run exactly after, in this case, 0 milliseconds, or exactly after whatever time you've specified. What it guarantees is that it will run at some point after that time has expired. And so by blocking the event loop here and running this synchronous code, we're essentially delaying the setTimeout from running. We're just feeding stuff onto the call stack endlessly for those 5 seconds until it's finally done. And then we can pick something up from the callback queue and push that onto the call stack. So good principle there is that it's not a guarantee for that exact moment, just sometime after that moment. Okay, and then for completeness, we could look at setInterval as well. We'll clear this out here. So setInterval does pretty much the exact same as setTimeout, except for interval will run basically in an infinite loop. It will continue to execute your method after a certain or every specified amount of time. So you can see here, we're going to console log first. Then we're going to set up some stuff for our second method, which is going to be run in an interval, and it will simply console log second up to 5 times until we clear the interval. And then we'll run third. And so if we run this demo again, so we've got first, third, and now it's going to log second 5 times. So nothing too surprising here. This is the exact same behavior as setTimeout, except for we're able to run in this interval, having this asynchronous loop happening. And then just for completeness, if we wanted to do that, add 0 milliseconds as well. You'll see that it functions the exact same as setTimeout, where it's not going to happen exactly after 0 milliseconds, but it will be some point after 0 milliseconds. So we can run this again. We've got first, third, and then second. So again, it will go to the timers API and then go to the callback queue. And then once the call stack is empty, we'll pop it off. Okay, so now let's look at one more with setTimeout, just for completeness here. The thing about the callback queue is that it is a queue, which means the things that get pushed into the queue are going to happen first in, first out. And so if we had maybe 3 timeouts here, we're going to put them all for 500 milliseconds. And then we ran this. You'll see they'll execute in that order for second, third. And if we were to run this again, it will execute in the same order. And it's going to be consistent. So there's not going to be any surprises or race conditions where like it runs first, third, second, or anything like that. It's going to happen in the order of the queue that you've specified. Okay, so everything we've covered so far, this is applicable in the browser with these methods of window.setTimeout and window.setInterval. And it is also applicable in Node.js with their methods for setTimeout and setInterval. And so now if we look at our next example, Node.js introduces another method. This one is called setImmediate. And so let's go through a few examples. We'll leave it kind of a mystery of how this is working, and then we'll go through the diagrams of the Node.js event loop and dig into it. But let's take a look and see if we can get kind of an intuitive grasp of what's happening here. So we have our 3 methods again, first, second, third. We're going to call first. We'll call setImmediate with second, and then we'll call third. So let's see what's going to happen. Take your guess while we get this set up. And we'll go. Okay, so we got first, third, second with setImmediate. So it appears that it's an asynchronous method. And it looks like it functions kind of like a setTimeout with a 0 millisecond delay. So it does get sent off to these APIs, which then pushes it onto the callback queue. And so the rest of the code is going to execute. That third is not going to wait for it. So we get first, third, then second. So it works kind of like setTimeout. So now let's look at, okay, what if we mixed setTimeout with setImmediate? So we've got our first, second, third methods again. We can call setTimeout with a 0 millisecond delay. We'll call setImmediate and then call third. So now this is hopefully a more interesting question is, okay, what's going to happen here? Does setTimeout happen first or setImmediate? So we'll give you a second to take your guess, your mental note. All right. We got third, first, second. So the third is our synchronous method. So you can see we're going to run down this thing. We're going to call setTimeout. It's going to go over to the timers API. The setImmediate is going to go over to that API. And then third is just going to execute. And we got first and second. So setTimeout, setImmediate. So timeout appeared to be immediate. So then we might wonder, okay, is it just because of the order that we called? So what if we swapped these out real quick? So now this is basically the same thing, but instead we're going to call setImmediate first and then setTimeout. So again, if we go back to the other example, it was timeout, then immediate. If we come here, it's now going to be immediate, then timeout. So let's run this again. And we'll leave the 12 demo up just so you can see the difference here. Okay, got your guess? Okay, so we got third, and then our timeout and our immediate. So even though we swapped the order, we got the same results again. So you might be thinking to yourself, okay, so setTimeout always takes precedence over setImmediate, maybe? Maybe that's the case. Let's test that theory. Let's look at another example. Let's do a whole bunch of mix and matching. So we've got just 4 method calls to setImmediate, and then we've got 4 method calls to setTimeout. We just labeled them each 1, 2, 3, 4. And then we're going to call them in a whole bunch of different orders. So first we'll call immediate, then timeout, then immediate, then timeout, then timeout, immediate, immediate, timeout. So what's going to happen here? This is a little more involved. We'll clear that out. Okay. Okay, so what happened here? Now immediate has beat timeout. And you notice that they're grouped. We've got 4 set immediates and 4 set timeouts. We could run that again just to see what's going to happen. So we've got the same thing, 4 immediates and then 4 timeouts, 4 immediates, 4 timeouts. Keep on running it. And hopefully, if this will cooperate for me, we'll see a surprise, or we might not. There we go. Okay, we got a surprise down here. So how about this last one? We've run this exact same code probably 8 times now. But now this time we got a different result. We got set timeout 1, and then we got set immediate 1 through 4. And then we've got set timeout 2, 3, and 4. So what happened there? They're not grouped anymore. They're somewhat grouped, but this timeout managed to escape to get up here. So it appears that there's some sort of race condition, some kind of indeterminacy in here. And then just one more, just for fun, and then we'll start explaining some of this. Hopefully it'll make sense. What if we did the same thing where we have 4 calls to set immediate, 4 calls to set timeout? We're going to call them in kind of a random order. But we're going to do this inside of this read file method from the FS package. So this is for interacting with the file system. So we're going to read a file here. What's going to happen now? So let's run this. And okay, so the immediates beat the timeout every time, and they're in their groups. And we can run that over and over and over. And immediate will always win. There's never going to be a timeout that escapes to the beginning. Okay, so what's going on here? How is this all working underneath the hood? And so to understand that, to understand how this behavior works with set timeout versus set immediate, is we need to get a better understanding of the Node.js event loop. So not just the JavaScript event loop, but the Node.js event loop. And so if you were to read the Node.js docs, they provide this diagram, and they say that the Node.js event loop has several phases, and there are at least 6 of them. They leave out a couple that they kind of wave their hands and say, don't worry about these. But they list at least 6 here. And so they say, okay, so there's this timers phase, there's a pending callback, so there's idle prepare, poll, and then we're going to check for incoming connections, check, and then close callbacks, and then it will loop back up to timers. And then they give another explanation. So this screenshot is just straight out of their docs. And so they give an explanation saying that, okay, so what happens in each phase? So in the timers phase, they say that executes the callbacks from set timeout and set interval. During the pending callbacks phase, that executes IO callbacks that were deferred to the next loop iteration. And when we talk about IO callbacks, that's usually working with the file system or network requests. We've got idle and prepare, which is only used internally, so they just say don't worry about that. We've got poll, which is going to get new IO events and execute IO-related callbacks, which is a whole bunch of callbacks except for timers and set immediate and close callbacks. Then we've got the check phase, where set immediate callbacks are invoked, and then close callbacks, like when you close a socket connection. And so when I read that with the Node.js docs, I was trying to kind of reconcile, okay, we have this description here, and then we have, you know, this diagram that everyone shows about the JavaScript event loop. But how do you reconcile those two ideas? And after reading the docs many times, it finally hit me that what they're trying to say here is that the Node.js event loop has multiple callback queues. Each of their phases has its own queue. And so that can help explain the behavior of set timeout and set immediate. And so if we want to combine this idea of these Node.js phases along with our simplified model of the browser's JavaScript event loop, we get something that looks like this. which is a little more complex. And so the top is the same. So we've got this heap, we've got our memory where our functions and objects and variables and everything are stored. We have our call stack where functions will be pushed onto the stack and popped up and executed. We have the now Node.js APIs instead of web APIs. So with Node, we're not going to have a DOM that we're interacting with, but instead we can interact with the file system, with the database, with the network, and then still timers with things like setTimeout and setInterval. And then we have all these different queues. And so we have these timers queue, the pending callbacks queue, the idle prepare queue, poll queue, check queue, close callbacks queue, and then two more that they didn't talk about, but that we'll get to in a little bit. And these are these kind of sneaky queues that aren't quite phases, but they can steal away the current operation of what's happening in the event loop with this nextTick queue and the microtask queue. And so the Node.js event loop has a lot more going on to it than the normal JavaScript event loop that you think about in the browser. And so let's go look at with this filled out now, taking that information from the phases of what gets executed when we're in the timers queue, things like setTimeout or callbacks from setTimeout and callbacks from setInterval will get executed. When we're in the pending callbacks, we've got deferred IO callbacks, the idle prepares, again, just kind of a mystery. The poll queue will be IO related callback, and then check queue is setImmediate callback, and close queue will be close callback. And so when we're running these examples with setTimeout versus setImmediate, what's really going to happen is that if you're running a combination of these methods inside of just like the main module in, just a main module that you're running with Node, their docs say that the order in which the setTimeout or setImmediate callbacks are run is going to depend on the speed of the process. And so really it's just kind of a mystery of what's going to happen here. And that's why we saw that sometimes setTimeout came first, sometimes setImmediate came first. It really just depended on which one of the APIs could run and push those onto the callback queue, and then at what point in the event loop you actually were. But then for our example where we read the files using that fs.read file module, we saw that it consistently executed the setImmediate callbacks before the timers callbacks. And the reason for that is that when you're doing IO related work, so with the file system here, you're in this poll queue. And so the very next thing to execute is going to be setImmediate always. And so setImmediate will always run first before setTimeout as long as you're in some sort of IO operation. Okay, hopefully that makes sense. And so this was honestly like the biggest revelation for me, was that the Node.js event loop has multiple callback queues, not just a single callback queue. So with that, these examples should make a lot more sense. We don't necessarily need to run them again, but again, the setImmediate, it is asynchronous. It's getting pushed into the callback queue for setImmediate. Versus timeout, they're going to run in an indeterminate order. So timeout might be first, might be immediate. It's going to depend on the speed of the process. Same thing, no matter what order you run it in. They will be grouped because once you're inside of a phase, it executes all the callbacks in that phase's queue. And so that's why we saw these groupings of setTimeout and setImmediate. And then finally, once you're in this IO phase, it's going to the very next phase is the check phase, which executes the setImmediate, which is why setImmediate will always beat setTimeout when you're in any sort of IO operation. Okay, hopefully you're still with me here. So now let's look at the next one. So let's talk about process.nextTick. So this is another method that Node.js introduces. We've got process.nextTick, and let's run this. So we've got first, second, third. We've got first, then process.nextTick, second, then third. If you're seeing a trend here, you'll probably be able to guess what's going to happen. But it goes first, third, and then second with process.nextTick. So this is another method that kind of delays things to happen soon after. So it's not synchronous, it'll be asynchronous. Just as a quick time check, I know I have like 10 minutes left, including QA, so we'll try to wrap this up in the next 5 minutes. Okay, so we've got an asynchronous method, but now we might get kind of curious about the same thing we're looking at of setTimeout versus setImmediate. What's going to happen with setTimeout versus process.nextTick? Well, if we run that, we run this demo, and process.nextTick is going to beat setTimeout. That will consistently happen. Okay, so what if we did that with process.nextTick and setImmediate? Run that one. And process.nextTick will consistently beat setImmediate as well. And then just for fun, we could look at that with immediate and timeout and nextTick. We could run that again. And process.nextTick is going to win again with setTimeout and setImmediate being able to flip-flop back and forth. Those could run in an indeterminate order. But then if we put that inside of our method to read a file, so we're into IO related stuff now. If we run this, we'll leave that 19 example up. We're going to run 20 now. Now you can see these two flip-flopped. So setImmediate's always going to beat setTimeout. And then if we wanted to look at, we'll pause for right now. We'll pause on that one. We won't look at that example yet. But so thinking about this, let's go back to the Node.js event loop. Let's go back to our demo here. Process.nextTick is kind of this special queue that doesn't really fit into any of these phases. What it does is it's a way to kind of circumvent the event loop. And as soon as any sort of operation is completed, if there's something that's in this nextTick queue, it can steal away JavaScript's attention to go execute those methods. So if you set up some stuff during the timers queue and then there's a call to process.nextTick, it could execute those right while you're still in this timers queue. And then once it's done, we'll move on to the next queue. And so really it can jump back and forth between any of these, during those phases. And so if we want to understand that one a little bit better, we could come over here to this last example. So this one is a little more convoluted, but we've got some methods set up. The one for the first setTimeout. We've got another one for the second setTimeout, which will console log setTimeout2, and then make 2 calls to process.nextTick. We could have a third setTimeout, and then we just have our methods for process.nextTick. So then if we run this, we'll first call setTimeout with our first timeout method, then our second timeout method, then our third timeout method, and then just process.nextTick. So then if we look at that example, this. Okay, so we first executed nextTick 3, and so that was on line 18. That was the first one to get executed because process.nextTick is going to beat out the timers. Next, we're going to get into our timers, so it'll execute 1, then it'll execute setTimeout2, and then that on lines 5 and 6 makes some calls to process.nextTick, and so then those are able to just steal away the event loop's focus and executes those right then. And then finally, we're going to get down to setTimeout3. I had a couple more examples for promises, but we'll forego those. So just to wrap up, a couple more, or one last slide here. Hopefully that's been interesting for you to see. Some main takeaways here. The Node.js event loop is complicated. There's a lot more to it than I thought there would be when I first volunteered to give this talk. I learned a lot in the last couple of months preparing for this. And so it is complicated, but if you want kind of a simplified model, the thing you need to understand is that the Node.js event loop just coordinates the work between the call stack and the callback queues. And that's queues plural. So takeaway number 3 is that the Node.js event loop has multiple callback queues. It's not a single queue. Takeaway number 4 is don't block the event loop. So like while we had that for loop that was running or the while loop, that can block stuff and cause delays in your other asynchronous code. So prefer these asynchronous callbacks over synchronous callbacks. Number 5, don't starve the event loop. So we saw how process.nextTick can kind of steal away the focus of what the event loop's working on. So if you were to call process.nextTick recursively, you can kind of get into the same situation as like almost like an infinite, while loop or something. Is you could get stuck there, starve the event loop. And then number 6, just if you're going to mix and match usage of setTimeout, setImmediate, process.nextTick, and promises, mix and match them with care. Understand how the event loop works so you won't have these surprises or these race conditions with your code executing. With that, I think we'll be done. So thank you for listening. We'll do some brief Q&A. Again, if you want to take a look at this later, I have the GitHub repo up here, and it's also in the chat. Thank you.
Hey, man, thank you so much for that, Tyler. That was super awesome. Wow, I learned so much. And you know what? Thank you also for all the time you spent. You said it took you several months to collect all this information, and it's really helpful, especially for me and everybody else out there. So let's get to these crazy questions we got for you. Okay, here's the first one. I'm going to bring it up on the screen. Are the Node.js and JavaScript event loops just different implementations of the same spec, or are they different specs?
Yeah, that's a good question.
Yeah, I know it is.
I'm trying to think what like the correct semantic way to say this is, but yeah, they're different. I'd say you could probably call them different specs of like, there is a concept of an event loop. And so they are different kinds of event loops, where the JavaScript event loop in the browser is a different implementation from the Node.js event loop on the back end. So however you want to call them, they are different concepts that share some of the same underlying ideas.
Right. That's awesome, man. That's a really good way to put it. Let's move on here. What resources do you recommend to learn more about Node.js internals and the event loop?
Yeah.
This is another good one.
Yeah. If you actually check out the GitHub repo that I shared in the README, I have a whole bunch of list of resources. So I would recommend those. The Node.js docs, the official docs, have a lot of good resources there. There are also a few good talks from tech conferences like these that have some good explanations that go into it in more depth from just what the official docs say.
Yeah, and I think that's one thing about Node.js that I learned. There's a lot of good documentation, right? It's not like it just leaves you kind of dry out there and hanging. It seems like it's really well documented, and there's some really good information when you get stuck, like me sometimes. Let's move on. What would be the best practice if I had to create child process and synchronize the response and a worker through the main thread?
Oof.
That's what I said.
Off the top of my head, I don't know. We haven't really covered this in the talk at all, but when you're thinking about Node.js as well, there's we talk about single-threaded JavaScript. Node.js is even a little more complicated than that, in that the event loop is single-threaded in Node.js, but then it can also offload these tasks to these worker pools. So kind of what you're alluding to here. And then the worker pools will then report back. Anyway, so off the top of my head, I don't know, but this would be a good one to get back to maybe.
Yeah, and that's a really good point. I think that something like this is something that, like you said, it's a single thread, and totally understand that. Okay, let's continue on. How does Node.js event loop differs from browser event loops?
Yeah, so we've kind of covered this a little bit in that first answer. But yeah, so they're similar concepts where the event loops coordinating work between the call stack and the callback queue. The biggest one is with Node.js. There is multiple callback queues and multiple phases. It's probably the biggest difference.
That's true. Yeah, and that's Node.js is the back end, correct? In other words, so it's different than kind of the Java, the browser where it loads and all of that. So okay, let's continue on. Okay, how do I prevent unwanted APIs when Node.js is updated or when required APIs are downloaded and installed?
I'm not sure I understand that question.
In other words, like if I'm going to install something new on Node.js, right, some new API, sometimes they bring in stuff that's unwanted, right?
Yeah, I'm really not sure if we're talking about like a latest version of Node.js, which then pulls in like a new version,
and you're updating, right.
Yeah, I honestly don't know how to answer that. In context with the whole event loop and stuff, like these methods really haven't changed at all since Node was created. So just things like setTimeout, setInterval, setImmediate, process.nextTick. So if it helps answer it all, like no matter what version of Node you're using, you're going to see consistent behavior with these. If they were to change those, that would be a fairly massive breaking change that I think they would they're smart to not change
Yeah,
that.
and I really like that answer because I mean sometimes it's not just creating the application, deploying it, is it? It's also the support in it, right? And so when you have updates, for example, to Node.js, and it sounds like what you're saying is it's pretty stable, so you don't really have to worry about like a major change or implementation if you were to update it or something like that. That's a really good answer, Tyler. I like that. Okay, could you please explain the difference between deferred IO callbacks and retrieve new IO events? Execute IO related callbacks in 2 different phases.
Yeah. So the docs are pretty vague about that. And I had that same
Mhm.
question of, okay, what's an IO callback versus a deferred IO callback? As far as I can tell, all of like the IO callbacks will happen in, geez, I'm gonna have to refer back to my diagram. All of those IO callbacks are gonna happen in that pull phase, anything that you're interested in. For that pending callbacks with like the deferred IO callbacks, those actually usually refer to like things that Node.js is using internally. So kind of more of their own little magic stuff. And so you're pretty safe to say that all of like your actual IO callbacks are going to execute during that pull phase.
Yeah, and then I think this is okay, we got 2 more. I'm going to try to run through these really quick. And by the way, I appreciate your patience hanging in there with all these great questions. Okay, could you explain how the race between, and you kind of mentioned this a little bit, could you explain how the race between setTimeout and setImmediate beat each other in that one execution case?
Yeah. So that's a fun one.
Yeah.
And so the Node.js docs, all they have to say is basically when you have calls to setTimeout and setImmediate in the main module of a file executed by Node, the timing will be bound to the performance of the process. I think that's roughly an exact quote, but they don't really give any more explanation behind that. And so I guess, I mean, what's happening is it depends on how fast, because again, it goes out to those external APIs, like out to these timers APIs, and then it pushes the stuff onto the callback queue. And so when we saw that one where like the timeout beat the setImmediates, and then we saw more setTimeouts, like it seems like it was, those external APIs were able to push the one timeout callback onto the queue and then push like those setImmediate ones onto the queue, but not the last 3 timeout ones. And then as the event loop's running, it went through the timers phase, it executed the one timeout callback, and then it went to the check phase, it executed the setImmediate callbacks. And then at that point, the process was able to finish pushing those remaining 3 setTimeout callbacks back into the timers queue. And so it looped again. And so, yeah, it's a little hard to wrap your head around, which is why it's kind of annoying that it's this indeterminate race condition type thing.
Yeah, that's a good point. Yeah. Does this one make sense? Use a software component analysis tool to inspect dependencies of dependencies.
I don't know what that would be referring to. There was a previous talking about the vulnerabilities in NPM packages, but
maybe so. Yeah. Okay, let's move on. Could you please give this is awesome. Yeah, I like this because this might be the last question. Could you please give final parting comments on microtasks versus what we saw till now?
Yeah, so the microtasks, that's kind of what we were getting to at the very end, where with that diagram, there were the 2 other little queues off to the side. There was the nextTick queue, which is for process.nextTick. And then there's also this microtask queue, which is for promises. And so those operate kind of the same way, where process.nextTick and promises, they don't have their own phase, but what they can do is they can steal the focus of the event loop as soon as the current operation has been completed. And then even within those, process.nextTick queue takes precedence over the promises queue. Anyway, so microtasks are kind of, they're ways to steal focus away from the normal progression of the event loop. But because of that, they can starve the event loop if you got like stuck in an infinite loop of microtasks or something. So anyway, that's a fun topic, and the Node.js docs kind of cover it a little bit, but they're lacking some depth there. So that's a fun one to explore. There are some other good blog posts on that.
And I came in earlier and I said it was really good documentation, and then you sat there and then you said, well, it's lacking. I'm like, great, that was a really good statement on my part.
They're great docs, but they are trying to
wonderful docs. Okay, Tyler. Last parting words. What do you got to say to everybody out there? This is your moment of fame. So go ahead, just say something.
Parting words. Yeah, just thank you for listening. I really appreciate it. If you want to get in touch, feel free to connect with me on LinkedIn or follow me on Twitter or read my work on Medium. But yeah, I'd love to talk with you.
Thanks, man. I appreciate it. Tyler, have a good one. Thank you so much for all the work you did, because what you said, and it was great information that you provided, and it was so awesome the way you presented it. Have a good one, man. I'll see you later.
Awesome. Thanks, Mike.